students, in last video we studied wave particle duality of electromagnetic radiation. In that we studied how electromagnetic shows the wave as well as particle in nature. Then the second point in last video, which is in wave particle duality of matter, means here we also studied the matter. It consists of a wave nature as well as in particle nature. So today's lecture we studied the chapter number 14, dual nature of radiation and matter. In that we studied the point de Broglie hypothesis. Then in 1924, Prince Louis de Broglie proposed that if the radiation consists of a dual nature, means radiation which is consists of in dual nature, means it sometimes shows wave nature and sometimes it shows particle nature, means radiation shows duality in nature. Also matter also consists of duality in nature, means it consists of wave nature as well as in particle nature. So in de Broglie also used the properties of frequency and wavelength. We know the relation between frequency and wavelength. Also he gives the relation between momentum P and energy. Then the equation of momentum and energy E upon C, where P is the momentum, E is the energy and C is the speed of light. This equation holds good when the massless particle traveling with the speed of light c, means this equation which is holds good when the massless particle traveling with the speed of light. This is the equation 1. We also know that the Einstein's equation of energy E is equal to h nu. E is equal to h nu. So E means energy, h means Planck's constant and nu means frequency. So substitute this E value in this equation. So P equation means momentum formula, which is equal to h nu upon c. This is the equation of the momentum. This means de Broglie also proposed the moving material particle of total energy E and momentum P associated with wave analogous to photon, means this momentum P and total energy which is analogous to photons, means h means we know h means Planck's constant, nu means frequency and c means speed of light. Also he proposed that the energy, total energy E and momentum which is associated with analogous to photon. Next we consider the formula for the frequency. Then frequency and wavelength which is associated with wave. Also frequency and wavelength associated with wave of mass m. Consider the particle of mass m and velocity v, means frequency associated with wave. Then symbol for the frequency is nu, which is equal to E upon h. This is the formula for the frequency. E means energy and h means Planck's constant. Then also wavelength also associated with wave. Wavelength associated with wave. Symbol for the wavelength is lambda, which is equal to h upon p. H means Planck's constant and P means momentum. Here also we know P is equal to m into V. Then substitute lambda is equal to h upon m v. This is the equation 2. This is the equation 2. Then here also we know the nu upon c, means nu upon c means 1 upon lambda. So this equation which can be written as h upon lambda, means P is equal to h upon lambda. This is equation 2. Then we also know that the wavelength value which is equal to h upon mv. This is the equation number 3. This is the equation number 3. Consider a particle of mass m and velocity v. Then it consists of a energy, kinetic energy, means kinetic energy, formula for the kinetic energy, which is equal to kinetic energy of mass m half mv square. This is the value of the kinetic energy. Convert this equation rearranging the term in the form of v, means v square which is equal to, here we write down ek, then v square is equal to 2 ek upon m. This is the value of the v square. Then here we calculate the value of v. Then if we calculate the value of v, then this equation which is written in the form of square root, so 2 ek upon m. This is the value of velocity. Here we calculate the value of velocity, but this equation means here we calculate the wavelength of electron, proton or something. Then here we calculate the wavelength value. So wavelength, which formula is equal to lambda h upon v. Substitute v value which is equal to 2 ek upon m, but v is in denominator. So write this in inverse form, m is equal to 2 ek. Then you write this equation in the form of h square root of m into square root of m multiplied by square root of m upon 2 ek, means square root of m means this equation means this square root of m and square root of m gives the m value, but means this m get cancelled. Then lambda is equal to, here is the h, remaining is, this is also square root, so together it form 2 mek. This is the value of the lambda. But here we consider a charge particle. Here we consider a charge particle of mass of charge q. This charge particle of charge q and its velocity is v. So the work done, which is equal to, means when the charge particle of charge q and velocity v, then there is a work. So this work value which is equal to qv, and this work provides the kinetic energy. So ek value is equal to qe, means this work done provides kinetic energy. Then kinetic energy value is equal to qv. Substitute this qv in this equation. Then lambda which is equal to h square root of 2 m qv. This is the last equation of lambda, means lambda wavelength. Here by using this equation we calculate the wavelength of electron, proton, neutrons and charged ions. In this case m is the mass of the particle and v means velocity. This velocity is very large because this value which is close to the speed of light, so velocity is very large. Then here by using this equation we calculate the wavelength of electron. Then next here we calculate the wavelength of electron. So for an electron moving through a potential difference v, then we calculate the formula for the lambda which is equal to h upon square root of 2 mq into v. Then m means mass, q means charge and v means its velocity, and h is the Planck's constant, v Planck's constant. Then here we calculate the wavelength in meter. Wavelength of electron in meter means h value which is equal to, h means Planck's constant, this value is equal to 6.63 into 10 raised to minus 34 joule second. Then m mass of electron which is equal to 9.11 10 raised to minus 31 kg, and the charge of this electron which is equal to 1.6 into 10 raised to minus 19 coulomb. Then substituting this value in this equation and find the values of lambda, means wavelength of electron. Then lambda which is equal to, h value is equal to 6.63 into 10 raised to minus 34. minus 34 upon in square root 2. M means mass of electron. This value which is equal to 9.11 into 10 raised to minus 31 multiplied by charge Q. Q means charge of electron. This value is equal to 1.6 into 10 raised to minus 19. And after that V is there. So multiplied by V. Then means here we calculate first 6.63 into 10 raised to minus 34 in denominator. Here we calculate 2 into 9.11 into 1.6. Here means 10 raised to minus 31 and 10 raised to minus 19 means base is same. So addition is there. So 10 is minus 31 minus 19. Minus 31 minus 19 gives minus 15 minus 50. So equation is 6.63 into 10 raised to minus 34 and multiplication and multiplied by V is there. V is there. So multiplication of this 2 into 9.11 0.1.6, this value which is equal to 29.152 and multiplied by V. But the addition is there means 10 raised to minus 50 and means if the square root is taken then it is multiplied by half. So this value is equal to minus 10 raised to minus 25 means 6.63 into 10 raised to minus 34 and it is value in numerator it is positive. Here is the value of minus 25 and if it goes numerator then this value is positive. So here is the plus 25. Then and square root of value of this 29.15152, this value which is equal to 5.4 in square root of V. 5.4 in square root of V. Then after division we get 1.228 upon square root of V and minus 34 plus 25 means 10. Here we use 10 raised to minus 9. This is the value of the lambda means lambda which is written in 1.228 into 10 raised to minus 9 upon V in wholes. V in wholes. This is the value of the wavelength of electron. I mean, this is the value of the wavelength of electron and this value is equal to 1.228 into 10 raised to minus 9 upon square root of V. By using this relation, we calculate the wavelength of proton, electron, neutron and means this also shows this also shows the wave in nature. And energy of these electrons which is in electron volts, so they show the wave nature. So in this video we studied the de Broglie hypothesis. Using the de Broglie hypothesis we calculate the value of the lambda. We know the formula for the lambda means de Broglie's equation which is equal to lambda is equal to h upon p. H means Planck's constant and p means momentum, and then derive the formula for the lambda which is equal to h upon square root of 2mq into v. Then substituting the values of h, m, q, then we get the last equation of lambda means the wavelength of electron which is equal to 1.228 into 10 raised to minus 9 upon square root of v. This is the value of the wavelength. Then the next video we will study the chapter number 15, structure of atoms and nuclei. Thank you.